All right, so this is 11-1. Notes for 11-1. So if you choose one item from a group of M items, the second item from a group of N items, and the total number of two items choices is M times N. The number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. This is called the fundamental counting principle. The fundamental counting principle. All right, so our first example says a restaurant offers 5 appetizers and 6 main courses. So how many ways can a person order a 2-course meal? So how many options of appetizers do we have? 5. So 5 appetizers. And we said we're going to multiply by the number of main course meals. How many main course meals do we have? 6. So 5 times 6 will give us how many options? 30. Boom, we're done. We are done. All right, so next example, question so far. Pretty good so far? Next example, an ice cream store sells 4 drinks in 4 sizes and 8 different flavors. So in how many ways can a customer order a drink? So how many options are there for different types of drinks? 4. Times how many sizes? 4. Times how many flavors? 8. Thank you. So if we have 4 times 8, how many different options are there? 128. 128. How could I help you? Questions so far? How are you feeling? Anyways, so thanks. A restaurant offers the following limited lunch menu. So the main courses, their options are beef, pork roast, chuck, duck, or quiche. Vegetables are broccoli, whatever. Okay, you see this list. So if one item is selected from each of the 4 groups, in how many ways can a meal be ordered? So how many different options do we have for our main course? 4 options. Times how many options do we have for our vegetables? 3. Times how many options do we have for their beverage? 5. And last but not least, how many options do we have for dessert? 4. So multiplying all of our different options together, how many ways can a meal be ordered? 240, thank you. $240. Questions so far? How can I help you? Last one. If you're taking a multiple choice test, that has 8 different questions. Each question has 3 answer choices with 1 correct answer per question. If you select one of these choices for each question and leave nothing blank, how many ways can you answer the question? So, for question 1, how many options are there? 3. For question 2? 3. For question 3? There's 3 options. For question 4? 3. For number 5, how many options are there? 3. Number 6? 3. Number 7, how many options? 3. And last but not least, number 8, how many options are there? 3. So mathematicians are efficient. So out of those 8 questions, we have 3 options for each. So what's the easier way of writing this? What? Close. You're close. There's 8 and a 3. To the 8th power. Good. So we have 8 threes. So we can write this more efficiently as saying 3 to the 8th power. So that'll be easier for us to plug into our calculator. So on our calculator, we have 3 to the power of 8. This arrow button, that's kind of diagonal from the 7, is our caret, and that will bring us to the 8th power. Boom. So we should have 6,561 different options. 6,561 different ways of answering the questions. So that is the notes for 11.1.